my name is Eric Fan. I'm a 4th year CS major at Georgia Tech. This year, I'll be the new RoboSub president.
Hi everybody, my name is Rahul Ramesh Babu. I'm a graduate student in aerospace engineering, and my role on the team was to develop the simulation.
Hello, I'm Justin Chow, a 2nd year CS student primarily involved with perception on GTMR.
Hi, I'm Ali and I'm a junior who studies computer science. I'm part of the perception team and I've been working on automating the data collection procedures.
Hello, my name is Pranit Dadu. I'm a graduate electrical and computer engineering major, and I'm part of the perception team for Georgia Tech Marine Robotics.
As in previous years, our sub is built with a tall frame, designed to be stable with a center of mass significantly below its center of buoyancy, giving it pitch and roll stability. With more limited degrees of freedom, the vehicle's dynamics are simpler and easier to control. An upgrade for the sub this year is a new pressure vessel, which houses our sensors, power systems, and computers. This serves to replace our previous aging hull and provides an opportunity to improve the organization of the internal systems. The new hull flanges use dual O-rings, making a better seal to keep water out. The new internal structure supports a card-based layout, with slots that can be filled with interchangeable components, making it easy to reconfigure and upgrade the system. The slot-based system allows for components to be wired up with relative ease. Eventually, the cards which currently act as mounting boards will be replaced with daughter boards connecting to a backbone, creating a much more streamlined electrical system. The sub has also received an upgrade for its front-facing camera. We installed an Intel RealSense tracking camera this year, enabling distance calculations and the use of SLAM algorithm. We also have planned to implement a hydrophone system, which will be self-contained and consist of 3 hydrophones. A big advantage of this sensor will be easy placement anywhere on the sub's body and the ability to use it on our RoboBoat and RAMV systems as well. The sub operates on an in-house built ROS architecture called Adept ROS. Adept ROS has a focus on modular design and is separated into 3 separate components: the navigation stack, the mission planning stack, and the perception stack. Other components include a cross-platform Qt-based GUI and drivers to interact with our system hardware. Arduino microcontrollers are also integrated into the ROS architecture. A major improvement to the stack this year is efficient allocation of system resources by making behaviors more modular. With new on-demand operations, nodes can dynamically switch behaviors that are controlled by a manager node through a service request. This allows for switching between different perception methods, control policies, and navigation algorithms, depending on the task.
The sub's perception system uses a machine learning framework, with object detection achieved with the YOLO algorithm. This year, this was improved with smarter hyperparameter tuning and improved data collection. Hyperparameter tuning needed to be optimized due to time and computing power constraints. In particular, genetic algorithms were explored as an alternative to grid search for finding the optimal parameters. This allowed us to expand our search space. In a genetic algorithm, sets of parameters are represented as chromosomes. And using a measure of fitness, the best chromosomes are selected to generate new ones, approaching the optimal solution in the search space. The chromosomes are also given mutations in order to avoid reaching a suboptimal solution. For our algorithm, chromosomes were initially generated randomly and evaluated based on accuracy. The results of this method were promising in simulation.
Data collection methods for perception have been improved by creating a filter to normalize images in various environments, allowing object detection to be more robust without the need to use data collected on site. This was made possible with a method enhancing the image and converting it to grayscale, performing relative global histogram stretching, and color correcting the image. This new filter would have saved time at the competition, as models trained on data from the Georgia Tech pool would now be usable at the transdeck, eliminating the need to collect and train on data from the new environment.
The team performed well last year, with strong performances in perception, depth and heading control, mission and task planning, and software architecture. This year, the team's strategy was to focus on solving problems in areas that are most in need of improvement. Improvements were made to hydrophone systems and visual odometry to facilitate better navigation. Prior to the pandemic, the sub was also tested on multiple occasions in the Georgia Tech pool. This allowed the team to calibrate and test the stereo camera for visual odometry. There was also a focus on revamping the hardware to improve its reliability. This involved incorporating a new pressure vessel into the design and using additive manufacturing techniques to prototype new parts. Another component of the strategy was allowing for better testing through an improved simulation. This was very helpful once the team was forced to work remotely. We are very prepared for the gate task and buoys task, so we have a 100% confidence rating in completing them. For the bin task, we have an 8 out of 10 confidence rating in the dropper component and a 2 out of 10 rating for the lifting component. Since we don't have a torpedo launcher, our confidence in the torpedo task is a 1 out of 10 because there's always a chance. For the octagon task, we have a 6 out of 10 confidence rating with the hydrophone equipped and an 8 out of 10 confidence rating using estimated commands using Google Maps. Improvements to our simulations also allowed for continued testing during the pandemic. A simulation environment to simulate the gate task was created, allowing the logic of the system to be tested. In this screenshot, the sub is performing a simulated gate task with a CAD model of the gate. The sub is using the YOLO object detection algorithm and using our sub's PID control logic to perform heading and depth control to properly navigate to the side with the traffic light. Additionally, one of our members had access to a 3D printer and was able to prototype the internal structure of our pressure vessels after we went remote.